All right, guys, let's see. Number 5. So we have f of x is equal to, we have a quotient here. So 5x squared plus 8 all over 4x cubed. Okay, I'm going to need some room on these. Okay, so we go right here. We go to our quotient rule. Okay, right here. Okay, where you're taking the derivative of a fraction. And notice the derivative, we get the denominator, v squared, becomes our new denominator. Okay, and then up here, notice it's the denominator times the derivative of the numerator, right here, minus the numerator times the derivative of the denominator. Okay, so when you set this up, you got to be careful with this rule. Okay, this is a rule that normally will bother people at the beginning. Okay, so let's see. Okay, so underneath, we're going to get the denominator squared. So the whole thing, 4x cubed, we got to square that. Okay, and then notice we're going to go the denominator, v, times the derivative of the numerator. So it'd be the denominator, 4x cubed, times the derivative, d dx, of the numerator, 5x squared plus 8, minus the numerator, our 5x squared plus 8, times the derivative of the denominator, 4x cubed. Okay, so it's just a pattern. You just got to work hard to keep it right. The more you practice on it, the better off you'll be. Okay, so let's see. Let's make sure we got it set up right. Okay, obviously this is f prime. I'm doing my f prime. Okay, or I shouldn't put that right there. Okay, I should put this right in here. Okay, this is my f prime. Okay, so we have the denominator squared down below. Okay, then notice I take the denominator times the derivative of the numerator, which is 5x squared plus 8, minus the numerator times the derivative of the denominator. Okay, and then I have to go ahead and just use my algebra and get going on it. Okay, so this guy I'm calling it f prime of x rather than dy dx. Okay, it doesn't make any difference. So my f prime of x equals, okay. Let's see, up here I've got the 4x cubed times, well, when I take the derivative here, derivative of 5x squared is 10x, the derivative of 8 is 0, so it's just times 10x, minus my 5x squared plus 8, times the derivative of 4x cubed, so that'll be 12x squared. Okay, and then down below I square everything, so we're going to get 16x to the 6th. Okay. All right, so let's see. This guy, I'm just going to get 40x to the 4th minus, I got to distribute this, and then afterwards I got to distribute a negative. Okay, so let's see. 12x squared times 5x squared is, what is that? 60x to the 4th. And then 8 times 12x squared, 80 plus 1696 x squared, all over 16x to the 6th. Okay, and let's make sure that 8 times 12, I got that right. I'm pretty sure I'm good. 8 times 12. Okay, 96. Okay, so we are going to get 40x to the 4th minus 60 x to the 4th minus 96x squared all over 16x to the 6th. And let's see, I've got some similar terms up above, so that gives me a negative 20x to the 4th minus 96x squared all over 16x to the 6th. And then I got to reduce it. Okay, so I'm thinking up above, I know I have a factor of x squared. I think I also have a factor of 4. Okay, 96 divided by 4. Right, okay, so I'm going to I don't like the double negatives there, so I'm going to pull out a negative 4x squared from both of them. Okay, so that'll give me a 5x squared plus, okay, let me see again, 96 divided by 4, 96 divided by 4 gives me 24, so it'd be plus 24 all over 16x to the 6th. Okay, so notice everything up above cancels off other than the negative sign. Okay, so I got a negative. Okay, I'm left with 5x squared plus 24. And then down below, reduce it by 4, that takes me down to a 4. Reduce it by x squared, it takes me down to x to the 4th. Okay, and you got your final answer. Okay, now you're not always going to end up with something that can be reduced. A lot of times you end up with an answer and there's nothing you can do with it. But with this one, we could reduce it. Okay, we got one more problem to do. Very similar to the last one. Ooh, I get two number 5s. That's number 6. Okay. All right, so I have f of x equals, I've got x squared plus 7x plus 10 all over 6x minus 7. Okay. All right, so let's see my derivative, f prime or dy dx, whatever you want to call it, doesn't make any difference. F prime of x. Okay. So again, you go back to your rule right here, your quotient rule right here, and we know we're going to get the denominator squared, so I get 7x minus 7 squared down below, 7x minus 7 squared, and then right here you're going to go the denominator times the derivative of the numerator. So denominator times the derivative of the numerator, so I get 6x minus 7 times the derivative of the numerator, x squared plus 7x plus 10, minus, right here would be the numerator times the derivative of the denominator. So it would be the numerator times the derivative of the denominator. Okay, so I'd have x squared plus 7x plus 10 times the derivative of the denominator, 6x minus 7. Okay, then it's just a matter of calculating some simple derivatives and simplifying. All right, so let's see what we got going on. Okay, up above, I've got the 6x minus 7 times the derivative of here. The derivative of x squared is 2x. The derivative of 7x is 7. And the derivative of 10 is 0, so that's it. Minus x squared plus 7x plus 10 times the derivative of 6x minus 7. Well, the derivative of 6x is just 6. The derivative of 7 is 0, so I just get 6. And that's all over. I'm going to leave this guy in factored form for the time being. I'm going to leave it just like that. Okay, so let's see what happens here. Okay, I got to use the FOIL method here. So we're going to get 12x squared. Okay, let's see. That would give me 42 minus 14. 42 minus 14, pretty sure it's 28. 42 minus 14, right. 42 minus 14, so that's 28x. Okay, minus 49. Okay, now I'm going to distribute the 6 and the negative at the same time. So that'll give me a negative 6x squared. That'll give me a negative 42x. And that will give me a negative 60. And that's all over 6x minus 7 squared. Okay, so I got to collect similar terms up in the numerator and see what happens. Okay, so let's see. I've got a 12x squared and negative 6x squared, so that's 6x squared. I have a 28x and a negative 42x, that's negative 14x. and then I have a negative 49 and a negative 60. That's going to give me negative 109 all over 6x minus 7 squared. Okay, now the only way this can be reduced is if the numerator has a factor of 6x minus 7. Okay, so we ask ourselves, could I do that? 6x minus 7. And then over here, well, this would have to be an x. This would have to be a plus. And then I say, okay, is 7 a factor of 109? Okay, so 109 divided by 7. No, it isn't. Okay, so there's no way. Okay, right here. Okay, this would be a big nope. Okay, so even if the numerator does factor, okay, there's no way that I would have a factor of 6x minus 7. Okay, so that is one possible answer right there. Right there, there's nothing wrong with that. Okay, somebody might, expand the denominator, so they might write it as 6x squared minus 14x minus 109. And then if we expand that guy down below, we're going to get 36x squared minus, what would that be? 2 times 6x times 7, so that's 2 times 42, 84x plus 49. Somebody might do that. Okay, either one. Okay, it doesn't make any difference. I'm saying either one of those is good. I probably would just go with this guy, but it's okay if you decide to go there. Both of them are 100% correct.